In this video, I'm going to be looking at fractional distillation. So the only aim from this video is basically to know how fractional distillation works. So before we can understand how fractional distillation works, we need to understand what crude oil is made up of, or crude oil being the substance we separate using fractional distillation. And crude oil is basically made up of lots of different hydrocarbons. And different hydrocarbons have different sizes. So it might have ethane, it might have butene, it might have cyclohexane. And all of these different compounds are different sizes. And that's what allows them to be separated, because different sized compounds have different size van der Waals forces acting between them, which means they all have different boiling points. And that's the key thing with fractional distillation. So this is what a fractional distillation column looks like, or a fractionating column. And you'll see that it is cold at the top, and it is hot at the bottom. So we heat up the crude oil first, and we vaporise it before it's put into this fractional distillation column. So we vaporise the crude oil, and it comes in the bottom. And what happens then is that as the heated crude oil rises, it hits different temperatures as it rises up, and different hydrocarbons will condense at different stages up this fractionating column. So down here, at the very bottom, we'll get the stuff that didn't vaporise in the first place, such as bitumen or tar, which has a very high melting point. So that'll just come off at the bottom as a sludge. Now as we rise up, we'll get different products that condense at lower and lower temperatures until you get to the very top, where there are things that haven't condensed at all, haven't turned back into a liquid at all, and just come out the top as gases. So how might it get examined on this? Well, here's an example question. You can see there are 4 marks. There's 4 different points you have to mention when you're talking about fractional distillation. To get these 4 marks, you have to make the following 4 points. The first one being that all hydrocarbons have different boiling points, and basically that's what allows them to be separated. So different hydrocarbons have different boiling points. You then need to say why they have different boiling points. The next step is saying a boiling point depends on the size or the relative molecular mass or the chain length of a hydrocarbon. I would stick with size. So boiling point depends on size of hydrocarbon. So there's 2 marks. And then the next step is to say what's special about the apparatus that allows those different hydrocarbons to be separated because they have different boiling points, and that's the temperature gradient. So you then say that the temperature gradient of the column, and that's important that you say that. You need to say it's the column or the tower of the column is cold at the top and hot at bottom. And then you say which hydrocarbons will come off at the top and the bottom. So you say large hydrocarbons exit at bottom, small exit at top. So there are your 4 marks. First one for saying what's special about different hydrocarbons that allow them to be separated, so they all have different boiling points. Then you say why they have different boiling points, that depends on the size of the hydrocarbon. Then you say what's special about the column that allows the hydrocarbons to be separated, and that's the temperature gradient, which is cold at the top and hot at the bottom. And then you say where the different hydrocarbons will come off. So the large hydrocarbons come out at the bottom because it's hot down there, and the large hydrocarbons will have higher melting points. They'll still be liquids at hot temperatures, and the small ones come out at the top. So the ones that are still gases at, say, room temperature will exit at the top as a gas.